This is Honors Algebra 2 Pre-Calculus. We're doing homework review in section 10.8, number 85 on page 774. So we are given the equation r equals 4, and we are supposed to take that polar equation and do 4 things. Look at the symmetry, like analyze the symmetry of that equation, figure out when the r's are 0, like when r would be 0, so what are the zeros of this polar equation, figure out what the maximum value of the absolute value of r is, and then graph it. So here's the thing. Some problems are hard because you have to gut them out and they're really difficult and they're lengthy. And those are one kind of hard. The other kind of hard is a problem that is so simple that we don't see what's in front of us and we try to do a mathier version of what we need to do, when in reality it's a much more straightforward problem. So this is one of those problems that is so simple that when you see it, you realize that it's actually really easy, but if you tried to do it in a conventional math way, it would be really hard. So let's think about the equation r equals 4. There is no theta here. This is a polar equation, but it's a polar equation where it doesn't matter what angle you are at, you automatically walk 4 units out from the pole. Well, we have a word for that in math, and that's a circle, right? So if I were to graph this, so I'm actually going to skip to step 4 first, and I'm going to look at what this thing would look like. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So regardless of what theta, what direction I turn, I'm supposed to walk 4 units from this pole. So if I'm at the theta of 0, I walk 4 units out here. If I'm at a theta of pi over 2, 4 units out. If I'm at a theta of pi, 4 units out. If I'm at a theta of 3 pi over 2, 4 units out. But anywhere else in the middle, guess what? Also 4 units out. So that's a circle of radius 4. That was a terrible drawing, but you get the idea. This is literally a circle with the center at 0, 0, if we're talking polar coordinates, x comma y, and a radius of 4, right? So the reason I mentioned that if you try and do this in a mathy way, it seems a lot harder, is as soon as we look at a circle and we talk about symmetry, the answer is, yo, this is symmetric to everything, right? Because the 3 kinds of symmetry we're supposed to look for are, does this thing bend across this line? Theta is pi over 2. Well, yeah, it totally does. It's a circle. It bends, yes, symmetric. Is this thing symmetric around the polar axis, right? That's this axis. Well, yep, it's a circle. If I bend it that way, it's totally symmetric. And then if I rotate this thing around the pole, spin it, do I get the same exact shape? Oh yeah, it's a circle, I totally do. So the answer is it has all 3 kinds of symmetry. But again, like if you're trying to plug in the values, it's a lot harder because you spend a lot of time trying to figure out, well, where do I plug in the theta? And if you look, so on page 775, that's not right, 757, come on, dyscalculia. On page 757, they give you tests for symmetry, right? But here, they're not really applicable. Like, it's not that you couldn't try and do them. It would just make your life way, way harder than to recognize, yo, that's a circle. It's symmetric. Let's also talk about the zeros thing, right? So my answer to part 1 is, what's the symmetry? All of them, right? Then my question is, when is r 0? Never. R is never 0. So the second part, r doesn't equal 0. R equals 4. 4 does not equal 0. R is not a variable here. R is literally a constant 4, and 4 is not 0. Because if you go try and buy something for $4 from the store but hand them $0, they will say no, because 4 is not 0. Same argument when we do 3. We want the max value of the absolute value of r. Well, r is 4. So it's the absolute value of 4, which is just a 4, right? And it's not, now the back of the book is actually incorrect here. The back of the book says, so when you check your answer in the book, they say that max value happens at 0, pi over 2, 3 pi over 2, and I think, pi. I think I skipped one, right? But that's not right, because here's the thing, it's a circle. Everywhere r is 4. Like, it's easier to count it on the axes, but r is 4 here, and 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 everywhere, right? And then part 4 we did first, which was graph. So again, 85 is one of those problems that is masquerading as a hard problem by being so simple that you look at it and you're like, man, I can't even do any of those tests and I have no idea what I'm supposed to do. But again, if you can try to get your head out of that for a sec, you'll see that it's actually a much easier problem than you think it is.